Over the past decade, renewable energy has grown from a niche idea that many were skeptical of to an energy source that delivers a significant part of our country's power needs. Clean energy is now one of the world's fastest growing industries. Despite this continued growth, renewable energy generation in the United Kingdom fell by 1% in 2016, not because of a decrease in renewable infrastructure. In fact, the UK's capacity to generate renewable energy grew by 13.7%. It fell because 2016 had less wind and rain than 2015. Drawing energy from such a highly variable energy source has its drawbacks, forcing us to not over-rely on renewable energy and continue to use baseload power stations, which typically are fossil fuel powered. But what if we could find consistent sources of renewable energy that were less variable? What if we could build a giant solar farm in our deserts and transport the energy across the world without the worry of losing power through resistance in the cables? Or if we could place some form of wind energy generation high into the atmosphere where winds are consistent and blow much faster. As I explained in my video about the future airliner concept, the Aurora D8, when a solid body like a plane flies through a fluid, the fluid near the surface of the body flows slowly due to friction. This is called a boundary layer. The exact same thing occurs on the surface of the planet, and so as you go higher, wind speeds increase. This means the vast majority of the wind's total available wind energy is located in the upper atmosphere. Planes take advantage of this by flying in jet streams where tailwinds can reach 160 km per hour. For example, a flight from Dublin to New York takes nearly an hour longer than a flight from New York to Dublin. Wind turbines are typically placed on mountains to take advantage of the higher wind speeds, but that obviously has its limits. So how can we reach higher and harvest that valuable wind energy? Some companies have designed and built small turbines that are suspended in the air with a large helium balloon, but these produce very little power and are not easily scaled to a larger size. Another solution is to use kites. Last month, Shell invited me out to Make the Future Life, which is a festival of ideas and innovation in London, to speak with the inventor of kite power systems. KPS is a UK company which recently received £5 million in investment from Ian Schlumberger and Shell Technology Ventures, which invests in companies to accelerate the development and deployment of technologies to help meet future global energy needs. The more I spoke with KPS, the more the technology made sense, and I began to see where it could be used in places where wind turbines couldn't. Let's first look at how it works. The system consists of two kites that are tethered to a spool. This spool unwinds as the kite soars through the air at speeds of up to 160 km per hour in a figure of 8 motion. As the spool unwinds, it powers an electric generator, but also feeds a hydraulic accumulator. The hydraulic accumulator stores potential energy in the form of pressure that can be released to drive the generator to smoothen out variances in kite speed, an essential quality to make the system's energy output compliant with the grid's needs. Two kites are used and allows one kite to raise as the other is lowering, with a small amount of energy from the kite raising being used to respool the tether of the descending kite. This point confused me initially. I could not understand how this would not reach a point of equilibrium where the lift on each kite would equal and the kites would get stuck. But as the Chief Technology Officer explained to me at Make the Future Live, these are not drag bodies, they're lift bodies, with control surfaces that are controlled by a small robotic pod. This pod ensures the kites are flying at the optimal flight trajectories at all times. By varying the lengths of the bridles from tip to tip, the kite's roll is controlled, and the pitch is controlled by varying the length between the front and back. When the kite needs to be lowered, the pitch is changed and the kite glides back to its start position. So how much energy can these kites generate? KPS is currently building a 500 kilowatt version in the southwest of Scotland. This version uses two 16-metre wide kites. For comparison, an equivalent 500 kilowatt wind turbine would have a diameter of around 54 metres. These wind turbines are not cheap, being constructed mostly from steel and composite materials. To prevent damage to wind turbines in strong winds, the turbines will be shut off. The kite-powered system, however, can operate in hurricane-force winds, and in the event of a break, the relatively cheap tether will be the part that breaks, and the kite will be able to fly itself to the ground, as the controller pod is located on the upper end of the tether. If this test location proves successful, KPS has plans to scale the kite to a 3 megawatt version that would consist of two 50-metre wide kites. Where this system really saves money is reducing loading on the support structures. Wind turbine blades need to be strong enough to resist both the rotational motion and bending motion of the wind. The tower in turn needs to be strong enough to hold the weight of the structure and resist the bending load of the wind. And all this needs to be supported by substantial foundations both on land and sea. In comparison, the kite-powered system's main component that experiences significant loading is the tether. The ground station simply needs to be heavy enough to prevent the kites from lifting off the ground. This makes the system significantly cheaper. A study published in 2016 by the International Renewable Energy Agency found that the cost per megawatt hour of energy generated by offshore wind cost about $170, and that is expected to fall to about $95 by 2030. A study conducted independently of KPS found that Kite power could generate a megawatt hour for $62.5 by 2020 and $50 by 2030, significantly reducing the cost of offshore wind. This is particularly useful for countries like Japan that do not have a huge amount of shallow water surrounding them, as the continental shelf dives to 50 to 200 meters, too deep for traditional offshore wind turbines. KPS can deploy to these areas with a simple floating platform that would be attached to the ocean floor with cables. The onshore version can even be delivered on a flatbed that can be deployed in less than a day, potentially being used for disaster relief situations where energy has been cut off. Without a doubt, this system has the potential to revolutionize wind power. Bill Gates has even been quoted saying that he believes kite power has a 10% chance of being the world's magic solution to the energy crisis. I'd like to thank Shell for inviting me out to make the future live and giving me the opportunity to speak directly with the inventors of a technology that could help us address the world's energy challenges. As the world's population grows, so does our energy demands, and we're going to need increasing investments in solutions like KPS to ensure we can keep producing more energy with less CO2. This year's regional Make the Future festivals were held in Singapore, Detroit, and London. It's a great event that I highly recommend checking out when it visits your city. I learned a lot about the future of energy while there.